Hello. In this video, we'll talk about writing vectors and matrices in MATLAB. So we can start new live script. We can write in the command window, but also we can write on the file or the live script file. So save as, let's write matrix underscore vector. Remember, we should not use the space, the dash, or the dot in writing the file's name. So let's say that we have vector x, which is equal to vector or array 1, 2, and 3. The size of this array is 1 row and 3 columns. How we can write this in MATLAB? We can write that x equal, we open the square parentheses for the vector or the array, and we write 1. To write the second element, we have two options. We can write space 2 space 3, the third element, or we can separate the elements by comma. So 1, 2, 3. Let's compare between them. If we press run, we'll have the same result here. And in a small gray font, we'll see the size of x, size of the array. We also can see the size here. For the x, we can see the value. We can see that it's 3 elements inside it. Okay. Let's now see how to write a column vector. This is row vector. What if we want to write 1, 2, 3, a column vector? We can write x equal, open the square parentheses, and then the first element. To go to the second element, which is in another row, to separate between rows, we write or we use the semicolon. 2, the third row, 3. Now, when we run the code, we can see that x now is 1, 2, 3 in column vector, and the size is 3 times 1, 3 rows with 1 column. Okay. Now let's see how to write a matrix. Let's say, for example, that we have x equal 1, 2, 3, 4. The size of x is 2 by 2, 2 rows, 2 columns. We can write x equal, we write the matrix row by row. So the first row we have 1, 2. The second row, to separate between rows, we write semicolon. The second row is 3 and 4. Now we have here x, 2 by 2 matrix with the elements. Okay, let's now see how to do operations on matrices. Let's say we have matrix A equal to 1, 2, 3, 4, and matrix B equal to 2, 2, 3, 3. So matrix A equal to 1, 2, 3, 4. And then matrix B equal to 2, 2, 3, 3. We can write, let's run first, then we can write the semicolon in order to suppress the result. Okay, so this is matrix A and matrix B. When we add semicolon, if you remember, this one will execute the lines, but will suppress the result. We'll not see the results on the results side. However, they are there in the workspace A and B. How to sum two matrices, to find the summation of them. So matrix C equal to A plus B, as simple as this. And we run it, we can see that the elements will be added together, each element with the corresponding element in the second matrix. So 1 plus 2, that will give us 3. 2 plus 2, that will give us 4, and so on. Subtraction, the same. So D equal A minus B. The same way. Okay, for matrix multiplication, if you remember, we had a condition that if we want to multiply matrix A and B, and matrix A is 2 by 2, matrix B is 2 by 2, in order to do the multiplication, the number of columns in the first matrix should equal to the number of rows in the second matrix. And the result, which is D here, the size of the result will be the number of rows in the first matrix and the number of columns in the second matrix, which is here will be 2 by 2. MATLAB follows the mathematical rules. So A times B. We have it. If this is matrix A and this is matrix B, just to remember how the multiplication is done, we take the first row, multiply it with the first column, and then we have the first element. Then the second row with the first column, and we will have the first element in the second row. The first row with the second column in the second matrix, and we'll have the second element in the first row, and the second row with the second column will have the last element in the matrix. What if we have matrix A and B, and we don't want to multiply it using the mathematical rules? We want to multiply it element by element. We want to do the operation, multiplication, element by element. It means that we want to take 1, multiply it by 2, and the corresponding element. 2 multiplied by 2, 3 multiplied by 3. How can we do this? If we write A times B, it will follow the multiplication done in math. In order to do the operation element by element, we add dot. Dot before the multiplication, before the star, it means we will do the operation, which is multiplication, element-wise. Element by element. Dot subtraction or division, it means that we will do the division element by element. Dot before the power, it means that we will raise the power element by element. So let's see the difference. Let's say that V equal A dot star B. Now the result should be 1 times 2, 2, 2 times 2, 4, 3 times 3, 9, 4 times 3, 12. Let's run the code, and we got it. Okay. Let's say that we have matrix A and we have matrix M, which is 1, 2. The size of matrix M is 1 times 2. If we want to multiply A with B, this is 2 times 2, and this is 1 times 2. It will give us an error because the number of columns of the first matrix does not equal to number of rows in the second matrix. Let's see this. M equal 1, 2. Now let's say that we have F equal A times M. We'll have an error. Let's read the error. Error using multiplication. Incorrect dimensions for matrix multiplication. It means the dimension is not correct. These dimensions cannot be multiplied. Okay, what if we take the transpose of M? M transpose in math, it's that we convert the rows to columns and columns to rows. That will have 1, 2. How do we generate the transpose in MATLAB? It's easy. We just add the dot dash. above M. If we run, we got the result. Here, the size of M, now M transpose is 2 times 1. The size of A is 2 times 2. The number of columns equal to the number of rows in M transpose. And the result should be 2 times 1. And we got this result. Okay. In some cases, we need to generate or to write matrices that specific matrices that have like repeated numbers. For example, want to write x equal to 1, 1, 1, 1. In this case, we can write x equal to 1, 1, 1, 1. 4 ones, and we'll get it. What if we need to generate x that like contains 100 of ones? It does not make sense that we would write 100 times. So there are built-in functions for matrices in MATLAB. We'll talk about this in another video, but now let's like introduce it. The command ones will give us or will create an array of all ones. We give it 2 inputs, the number of rows and number of columns. Let's say we want to write this x. It's 1 row, 4 columns. Now when we run it, we'll get it. What if we need it to be 10 rows, 2 columns? We will get it. So instead of writing 1 for 20 times the total number of elements, we can use only the command ones, giving ones the dimension, number of rows and number of columns, and then we will get the matrix. We'll talk about these built-in matrices in MATLAB in another video in details. Thank you.